I guess that's it. All right, guys. So today we're going to talk about order of operations. And a lot of you guys know this. Because I know all of you have been exposed to it. But order of operations does get confusing. And what I would think some people would wonder is, these mathematicians, they come up with these ridiculous concepts, order of operations. Like, who needs that? It's ridiculous. It's so simple. Like, you just do 4. If somebody gave me 4 plus 3 times 2, that's so easy. Why would we need an order of operations, right? So Aunt Petunia comes up, oh yeah, I love doing this. This is so easy. 4 plus 3 is 7 times 2. Oh, that's equal to 14. Easy, right? Well, Rumpelstiltskin comes up and he does something different. He says, well, wait a minute. I wouldn't do it that way. I would do it like this. I would say, well, 3 times 2 is 6, so 4 plus 6 is 10.
Correct.
Oh my gosh. So suddenly we have 2 people who came up and did the same problem, and they did everything right, and they got 2 totally different answers. Now, how many people would agree that math would be a nightmare if everybody did the same problem and everybody came up with a different answer, right? I would. That would be a nightmare, right? I wouldn't even be a math teacher because there'd be no sense. There'd be no logic to math. We wouldn't be able to use it. We couldn't rely on it to describe our world, which is what math does. It describes. It's a language that we use to describe what's happening around us. So mathematicians said, this is not going to work. Both of these people did the right thing. They didn't do anything wrong. It's just that we have to choose as mathematicians which way we're going to do it. And so that it's always going to get the same answer. So they chose an order of operations. Notice an operation. What is an operation? How many people know? What is an operation? Give me some examples of operations. Well, what is an operation? In math, yes. In math, right? Not in surgery, right? In math. Anybody? So give me one. Yes.
Isn't it like something without an equal symbol? It's a problem without an equal symbol.
Okay.
Is an equal symbol?
That's true, but I want you to be more specific. Like, what is there are 4 operations, 4 basic operations. Indu, what would they be?
By addition, subtraction.
Yeah. Every plus sign is an operation. Every negative sign is an operation. Every multiply sign is an operation. And every division sign is an operation. That's what we're talking about when we say order of operations. It's order of which do we do first? Do we add, or do we subtract, or do we multiply, or do we divide? That's all it is. All right? So that's why they call it order of operations. So we have come up with this wonderful, I'm going to erase this one. Mathematicians came up with this wonderful little acronym. Acronym, is that what it's called? PEMDAS. There's another word for that. What do you call these?
Acronym is PEMDAS.
Yeah, okay, an acronym. So PEMDAS. And P stands for parentheses, right? So if I wrote it this way, then I could maybe write that out, right? PEMDAS. Maybe I should do it that way. And then PEMDAS, P stands for parentheses. Parentheses. E stands for exponents. And then we'll leave this up for a while because we're going to, M stands for multiply. D stands for division. And I know you guys all know this. A stands for add. And S stands for subtract. But even though you guys know this, I'm writing it up for a reason because these problems get confusing. And if you don't have this in your head, when I do PEMDAS problems, I will actually often write down PEMDAS right above the problem, and I will cross out one at a time. Are there any P's? No, I cross it out. Are there any E's? No, I cross it out. Are there any M's. Oh, yes, there is. So then I have to do that. And once I do that, then I cross it out and whatever. Yes, Elizabeth.
With multiplication and division, isn't it whichever's on the left that comes first if there's both?
That is
Same
true.
with addition and subtraction.
It's in order from left to right.
Yes,
Yeah,
that is true.
but not like with multiplication and subtraction. Then it would be
Correct.
just
Correct.
multiplication and
You are
division.
correct. You are correct.
Yeah,
So actually, I should add to this. Thank you, Elizabeth. And I'm going to say left to right. That is actually an important thing to keep in mind. Okay, so if that's our order of operations, that means we have to look at parentheses first. Do everything inside the parentheses first. Then we have to look at exponents. Do everything, get rid of all those exponents. Then we have to multiply. Then we have to divide. Then we have to add. Then we have to subtract. So if we use that, by the way, how does everybody knows PEMDAS? So I don't have to even, we don't even have to memorize it, right? Nobody has to memorize it.
No.
Like, please excuse my dear Aunt Sally. Do you guys all know that?
Yeah.
You heard that? So right, that's one way to remember it if you forgot.
What?
But
Oh yeah.
please excuse my dear Aunt Sally.
Oh, my old teacher taught
Okay.
me that.
That's just a way. If you don't remember PEMDAS, you know, I mean, when you first learn the word, it's like, what is a PEMDAS, right? Oh, I was walking on the road one day and I saw a PEMDAS, and he was so cute, right? That's not what a PEMDAS is, right? It's you know. So Rumpelstiltskin beat who was it? Aunt Delilah or something?
And Petunia.
Aunt Petunia, sorry, right. All right, Rumpelstiltskin beat her because he decided to use multiplication first. How many operations do we have in this problem?
Two.
Two. What are they?
Addition and
Multiplication and addition, right? So I go over here. Are there any parentheses?
No.
No. Are there any exponents?
No.
No. Are there any multiplies?
Yes.
Okay, so I got to do multiply first. 3 times 2 is 6. And then it says, are there any divisions? No. There's any additions?
Yes.
Yes. So now I'm going to add 4 to my 6, and I get my 10. And so that is the correct answer. That is the correct way to do that particular problem. So now we're going to do a bunch of problems, and you're going to start to see how they get done. One of the things that I have noticed is that people sometimes don't know when they have a hard time identifying when something is a multiply. Because sometimes we use parentheses, and remember, parentheses always means multiply. But parentheses also is used to group things, right? So really, parentheses have two different jobs. One is they're grouping things together, but the other thing is a parenthesis actually always does mean multiply. So even when it looks like the parentheses are only used to group things together, they're actually also multiplying times something outside that parenthesis, okay? So we have to keep that in mind. So I'm going to erase this one, and we're going to start doing just a bunch of examples just so you can start to see them. All right, so let's do the first one. So that was example 1 we just did. We'll do example number 2. So we'll say 4 times 3 plus 2 plus negative 3 times 5. Okay. So my operations, I have a multiply, an addition, I have a negative sign, right? And whatever. So, oh yeah, and parentheses are multiplying, right? All right, so I'm going to go back to my PEMDAS. I'm not going to immediately go 3 plus 2 is 6, and I'm not going to randomly do stuff. I go back to my PEMDAS, my P, parentheses. Is there anything in a parenthesis? Yes. Now, can I simplify negative 3?
No.
Not really. If it said negative 3 plus 1 in the parentheses, then I could simplify that. But I can't really. That's just a number inside parentheses. So really, that means negative 3. And then the parenthesis always means multiply. Now, are there any exponents? There's no exponents other than hidden ones as exponents. So how about multiply?
Yes.
All right, now I'm going to multiply from left to right. So I start on my left side of my equation. I see 4 times 3 is 12. And then I do plus. I'm not adding anything. I'm just going to rewrite everything else. Now, here, okay, I'll put a plus for a second. And then I have negative 3. Is that a multiply? Negative 3 parentheses 5?
No.
Yes, it is. Remember, parentheses always means multiply, right?
Yep.
So that is an example of one that is hidden there, because it doesn't look like a multiply, but it is a multiply. It's negative 3 times 5. Well, what's negative 3 times 5? Yeah.
Negative 15.
Negative 15. So I've got a plus, and I'm going to put negative 15. That's interesting. Well, I'll put parentheses, I guess. Why not? Now, I want to simplify this, though. I don't like, well, I don't know. That's okay. I can keep it that way. So what is, now I've done my multiply. Is there any division? I've got a plus, and a negative. There's no division, right? Is there any addition?
Yes!
Okay, and I got to go from left to right. So 12 plus 2 is what?
14.
All right, so we'll simplify it, 14. And then I've got plus a negative 15. So I've got a 0 here, number line. I'm going over 14. There's my 14. And then I'm going to come back 15. So here's 14. I came back 14, and I've got to come back one more. So that's going to give me negative 1.
Woo!
Right? So that would be my answer. Pretty straightforward, right?
What I don't understand is how do you know it's right? Because the 4 times 3 plus 2 plus negative 3 times 5. How do you know that's not the right answer?
Well, these are the same thing. I mean, basically, I'm using PEMDAS. I'm using that order to go through one at a time. So I've got to do parentheses first, but there's nothing I can simplify. So then no exponents, so I go to multiply. So I do my multiply, that's 12. I do my multiply, that's negative 15.
Yeah, that makes sense, but how do you know if you didn't do the parentheses, if you completely ignored the order of operations and you just did it left to right?
Yeah.
How do you know that's not the right answer?
Oh, I see what you mean. You mean theoretical, you mean like philosophy.
Yeah, how do you
I don't know the answer to that question. That's a really good question.
That's what always confuses me. It's
What was the question?
there's two different answers, but which one's right?
There's
Right.
the PEMDAS one, because everyone uses the system.
Everyone uses it, but how do you know it's right?
Let me think about it, and maybe tomorrow I'll come in with an answer for that. But there is a way to actually see that it is right. It makes logical sense, which I didn't mention that in the lecture so far, but it does actually make logical sense. It's partly also the way we have defined math and defined the way things work. But let me think about it and give you a better answer tomorrow, because that's a great question, really great question, awesome question. All right, so can I raise? I already did, so I guess I can. All right, so we got number 3, and they're going to just slowly get more and more complicated. Negative 5 parenthesis 2 minus 3 plus 6 parenthesis 3.
Oh, yeah.
Okay? Now, what I want you to see, though, is before you do PEMDAS, things look confusing. And they always look confusing until you've started to break things down using PEMDAS, right? So, my first thing, are there any parentheses?
Yeah.
Yes, but I can't simplify what's inside that. That's just 2, and that's going to stay 2, right? I can't do anything. I can't simplify the 3. So I've done what I can do with the parentheses, because what the P stands for is do what's inside the parentheses. If it was 2 squared, then I would do 2 squared, which is 4. If it was 2 plus 2 inside the parentheses, I'd do 2 plus 2, which is 4, right? I do what's inside the parentheses, but if there's just one number inside the parentheses, I can't do anything with it. That's it. I'm done. So then I go exponents. There are no exponents. You guys all know what exponents are?
Yep.
Right? The little numbers up high to the right. There are no little numbers up high to the right. Technically, there are exponents, but they're all little numbers, and the little numbers are 1. They're hidden ones, and that doesn't change the number. So now, there's no, okay, we've dealt with parentheses, we've dealt with exponents. Now multiply. Parentheses means multiply. So I see a multiply right here, and I'm going to start from left to right. It says negative 5 times 2. What's that?
Negative 10.
Negative 10. So I just write negative 10. Now notice I'm writing this right underneath it. I find that much easier. Some people like to do this. You know, they like to do minus 10. You know, and they write really small and they try to do it here. And it works, and it's okay, and if you can do it that way, fine. But if you're even slightly confused, you're much better off doing it right underneath, because it's really easy to see when you screw up. So negative 5 times 2 is negative 10. And then I'm going to just write my minus 3. And then plus, and now I've got 6 times 3, which is 18. Okay, now suddenly that to me looks so much easier than this. All right, so when I have a minus 10 on a minus 3 and a positive 18, I like to group my negatives together. So I have a negative 10 and a negative 10 and 3 more negative. So I'm going in the same direction. I'm going to keep the sign. And I'm going to add the numbers. 10 plus 3 is 13. And then so it's got negative 13 plus 18. So I could do negative 13 plus 18. Or I could think of it as 18 minus 13. It's the same thing. 18 minus 13 is 5, right? That one to me is easier to read than that one. I can do it either way. But remember what we learned. 13 minus 18 will be the same number as 18 minus 13. Just the signs will be different, remember? So it doesn't matter which one you subtract first. So we found 5. So tomorrow we'll finish this lecture and we'll actually do a lot of examples, okay?
Hey guys.